The voltage divider rule that you learned for DC applies for AC as well. And remember what the voltage divider rule said was that if you're looking for the voltage drop across some element or some portion of your circuit, it is directly proportional to the resistance of that portion of the circuit is to the overall resistance as well. So that would be Rx divided by the total resistance of the divider circuit times whatever that total voltage is across the whole thing. So let's say we're looking for V1 and V2, and we're going to use the voltage divider rule in this case. So V1 would be C1 over ZT. Remember, this was for DC, but for AC, we have to use impedance, times the total voltage across the entire circuit. So this would be E in this case. So what would Z1 be? Well, Z1 would be the impedance of our inductor here, which is 40 at 90 degrees, or you could say 40J. And then what's the total impedance? Well, that would be the impedance of the entire divider circuit. And I'm just going to go ahead and add this. I tell you what, I'm going to do this in rectangular form. So Z1 would be 0 plus 40J. That is our inductor. And then ZT is going to be 6.8 plus 0J. The 40 ohm resistor, 0 plus 40J. And the 22 ohm resistor plus 22 plus 0J. Times our phasor voltage, which is 60 volts at 5 degrees. Okay, so what is that? That's 40J on the top. And then we've got 28.8 plus 40J on the bottom. And if you're putting that into your calculator, put that in parentheses on the bottom there. Times 60 at 5 degrees. And that will give you 48.69 at an angle of 40.75. And for V2, that would be Z2 over ZT times E. And in this case, ZT is the same that we found up here. But we're using, for V2, we're using Z2 up here, which is just 22 over 28.8 plus 40J times that same voltage, which would be 26.78 at an angle of negative 49.25 degrees. So that's how we would use the voltage divider rule here. And I'll work out a couple more problems in